Hi students, now we are going to explain Newton's law of cooling experiment, which is a very important 5-mark question in the annual examination. Now this is the experimental arrangement. This diagram if you draw means it is better for you. You can see a metal stand from which a metal sphere containing hot water is suspended. So this is a copper vessel, copper calorimeter we can say, which is filled with hot water. And a thermometer is inserted to measure the temperature at every instant of time. Now when it is suspended and its initial temperature T1 is first recorded. Okay? Then with the help of a stop clock, for a few seconds or few minutes, we run the clock, and for a definite time T or dt, the final temperature T2 is noted. So first what we said, hot water is taken in a copper calorimeter, thermometer is inserted, its initial temperature T1 is noted, and simultaneously a stop clock is started. After a definite time dt seconds or minutes, the final temperature T2 is noted. Okay. Now the atmospheric temperature is also called as a room temperature, that is automatically recorded first. Okay. So now in this experiment, what is T1 means? There is a initial temperature which is a higher temperature like 90, 100 like that. Then T2 after a time dt seconds, then the final temperature, that is the low temperature, is noted. If you take the average T1 plus T2 by 2, that is only denoted as a symbol capital T. That is the average temperature. Average fall in temperature because it is cooling. Now Ts is called the surrounding temperature, the room temperature inside the physics lab. M is the mass of hot water taken inside the vessel. Now S is the specific capacity of water. Now you can see that every second some joule of heat is leaving the system, it is going out. So I will take dq is the quantity of heat lost by the hot water. So dq by dt, if I divide dq by the time dt, then dq by dt only is called rate of loss of heat, which is also called as rate of cooling. Okay. Now according to the statement of Newton's law of cooling, this rate of cooling is directly proportional to the difference in temperature between the body and the surroundings. Okay. So now this T minus Ts is having a negative sign. Why there is a negative sign? Because initially at the beginning more quantity of heat will leave the system, and as the time proceeds, the quantity of heat leaving the system will be reduced. Continuously it will be decreasing. That is why a negative sign is introduced here. So rate of cooling dq by dt is proportional to minus of T minus Ts, or dq by dt is equal to minus of a constant A into T minus Ts. This is the first equation, which is a statement of Newton's law of cooling. And A is a positive constant. Okay. Now we also have studied thermal capacity of a substance. Is it not? Thermal capacity of the substance dq is equal to mass of the substance into its specific heat capacity into dt, the difference in temperature. Is it not? So from this equation I am going to divide left hand side and right hand side by the same time dt. So that left hand side will become dq by dt, right side will become m into s into d capital T divided by d small t. Take care in writing these symbols. D capital T means change in temperature. D small t means what? Time taken. Okay. So from these equations 1 and 2, left hand sides are equal. So I am going to equate the right hand sides. Now rearranging the terms in the above equation, the change in temperature dt is taken to the numerator, and T minus Ts, which is also the change in temperature, can be brought to the denominator. All other terms are shifted to the right hand side. So minus A divided by m into s into this d small t, the time taken on the right side. Now this T minus Ts is also a variable, okay? So I am going to integrate the above equation so that the integral of 1 by T minus Ts into dt is equal to this constant minus A by ms into integral of d small t. Time also is a variable from 0 seconds to 5, 10, 15, 20 like that seconds it is changing. Now 1 by x dx is equal to log of x to the base e. That is a natural log. Therefore 1 by t minus ts if we integrate means it will give you log of t minus ts to the base e. Base e exponential constant. So this is called the natural log. So minus a by ms into t plus integration constant which depends on the time, okay, b1. So the same can be rewritten as ln of t minus ts. Ln means natural log of t minus ts equal to minus at by ms plus integration constant b1. So b1 is the integration constant. Now ln of x is equal to y means then x is equal to e power y. There is a conversion factor in mathematics. So t minus ts is equal to e raised to the power minus at by ms plus b1. Now e power a plus b is equal to e power a into e power b, another formula in mathematics. So the right hand side is again written as e raised to the power minus at by ms multiplied by e raised to the power b1. Left hand side is t minus ts. So this is now equal to e power minus at by ms. In place of e power b1 I substitute another constant b2. So b2 is equal to e raised to the power b1 which is a constant. So now the above equation becomes t minus ts is equal to this constant b2 multiplied by e power minus at by ms. This is another important step, okay? Now we need a t, final expression for t. Therefore the average temperature t is equal to this minus ts is shifted to the right side as ts plus b2 into e power minus at by ms, okay? So this is the final equation in Newton's law of cooling. Now a cooling curve, a graph between the temperature and time taken has to be drawn. Temperature is taken along the y-axis in degrees Celsius and time is taken along the x-axis in seconds. Now children, whenever a system is cooling from a higher temperature to a lower temperature with time, what should be the final temperature? It should be equal to the surrounding temperature. It cannot cool below the surrounding temperature, is it not? So this is the cooling graph. Now equation 3, this is T minus Ts. This is the change in temperature, okay? This is the change in temperature of the body with respect to the surroundings. And that is only equal to what the rate, proportional to what the rate of cooling, okay? So you have to complete the answer by drawing the cooling curve. This diagram, though it is not essential in the examination, it is better if you draw for your understanding, okay? I hope you must have understood well, fine.